Whether it's losing weight or just making better choices, we all get that first of the year boost when it comes to nutrition and getting healthy. But for astronauts on the International Space Station, it's a daily routine. They have to think about everything they eat and how it will affect their overall health. So we study nutrition in space, and the things we're learning from these astronaut studies are shedding light on problems we face here on Earth, such as vision, bone loss, and vitamin D deficiencies.
What we're doing is trying to evaluate nutrition and basic physiology, if you will, in astronauts while they're on the space station. And it's very similar to when you go to the doctor and you get a checkup. They'll draw a blood sample, they'll collect a urine sample, and we'll look at things in there to see how you're doing. That's in essence what we're doing with a cruise. We collect blood and urine samples during space flight. Over the course of a 6-month mission, we collect 5 blood samples and 5 urine samples, and we measure a whole host of things in those samples to look at vitamin status and mineral status. We look at things like bone metabolism, we look at some muscle markers, some oxidative damage markers, you name it. There's a lot of biochemistry in that blood and urine that can tell us how your body's doing, in our case, during space flight. We're looking at different chemicals that have helped us better understand some of the medical issues that occur during spaceflight. And the most significant one of those is we've found crew members coming back from space station with vision problems. Crew members that went up with perfect vision and came home needing glasses, in its simplest explanation. And what we found in data from blood samples is that there are differences in the biochemical profiles of crew members that had vision issues compared to those that did not. And we're working to follow up on that to try to help better understand the vision changes during flight. The research that we're doing in flight from 2 perspectives has a lot to do with people on Earth. Just understanding basic physiology, basic nutritional requirements can help us better understand those same things on Earth. The bone loss that we see during spaceflight is very similar to some bone diseases that people on Earth get, and we're studying them in a very healthy population. So that helps us better understand the nature of those diseases. And then on the other hand, as we develop means to help counteract those diseases or those issues during spaceflight, those too have direct application for people on Earth, be it dietary changes that can help mitigate bone loss during flight. One of the things is that, we did some studies to help better understand how much vitamin D people needed during spaceflight. And we've now got to the point where we're maintaining vitamin D levels in our astronauts. Those data were actually incorporated in the group, the Institute of Medicine, who sets the recommended dietary allowances, the RDAs for the population. Our study was one of the many studies that those groups looked at to help better understand vitamin D requirements for people on Earth. So there's a lot of interaction, but again, human health and human disease, it overlaps entirely. We still have a lot of work to do. Based on the many findings that we've gotten out of our first nutrition study, we've actually evolved that into a follow-on study, what we're calling the biochemical profile experiment, where again, we're collecting blood and urine samples to look at the adaptation of spaceflight. We're also starting up some what we call the integrated nutrition study, where we're looking to modify people's diets to provide healthier diets to see if we can use those as ways to mitigate some of the negative effects of spaceflight on the human body. And those are in the very early stages, but hopefully in a few years I'll be back talking about the exciting results from those as well.